This lesson's on complex numbers. This is the the imaginary part of our algebra here. The solutions that we're getting that have no the problems that we're getting that have no real solutions. And to give a demonstration, I've got one of those equations here, x squared plus 1 equals 0. If we were to solve this, we have x squared equals negative 1. And we know that there's no number that we can square to get a negative number. So we would say x is going to equal positive or negative square root of negative 1, and that doesn't exist. So up until now, we've had to stop here and say that that's not a real solution. The way around this, how mathematicians got around this dilemma, was they invented something called the imaginary unit. And this is a clever way to solve the problem, and it opened up an entirely new area of math. They said, we're going to let the square root of negative 1 equal something called I. And that allows us to call this problem, since the square root of negative 1 is I, we have plus or minus I. And it gives us another set of numbers to deal with called the complex number system. So what a complex number is a number of the form a plus bi. Where a and b are going to be some numbers. Sometimes there's zeros and negatives and positives, and so a complex number might look like 3 plus 5i. That is a complex number. It has two parts. It has a real part, which is this guy here, and it also has an imaginary part, which is going to be this part. Oops, missed it there a little bit. And so that's what a complex number is. And again, this opens up an entirely new area of math for us called the complex plane. And there's a lot of neat and cool stuff that goes on in there. If you look at the end of our chapter on the fractals, the Mandelbrot set, the Julia set, that's all some higher level stuff that that you could look into if you're interested. Let's go to our second slide here. What I have here is an exploration of the powers of I. If we take I and we raise it to a different power, what are we going to get? So at this time, maybe you want to try a couple of these, and feel free to pause the video. I'll go ahead here and do a few of these. Knowing that I is the square root of negative 1, when we look at I squared, well, that means I times I. So we are going to have the square root of negative 1 times the square root of negative 1, which is equal to negative 1. So pause this and give a shot at the next few, and we'll resume it and see if you end up with the right thing. So hopefully you've paused, and we'll try a few of these here. I cubed. Okay, this is going to equal, let's turn the pen on again. This is I times I squared. Well, I squared we already know is negative 1, so this is going to equal negative I. I to the fourth. What we can notice about I to the fourth, well, that's I squared times I squared, so that's going to equal, I'll write it out here for you. That's going to equal negative 1 times negative 1, which is going to equal positive 1. Let me circle these here so they stand out a little bit more. Now we go on to I to the fifth power. Well, this is going to be I times I to the fourth. There's one way of thinking about that. Well, I to the fourth we already saw is 1. 1 times I is I. And of course that's the square root of negative 1. So keep on going. Again, feel free to pause at any time. And what you should notice here is a pattern that emerges here. I to the sixth power. We can think about that a bunch of different ways, but let's see. One way might be to say, well, that's I squared times I to the fourth. And we know that I squared is negative 1, and I to the fourth is positive 1, so when I multiply that, I get negative 1. I to the seventh power, I can think of this a bunch of different ways. I'm going to call it I to the fourth times I to the third. Okay, that makes I to the seventh. Well, I to the fourth we know is 1. I to the third is negative I, so this once again is negative I. I to the eighth, probably get the hang of it by now, is I to the, a bunch of different ways, but I'll say I to the fourth times I to the fourth. I to the fourth is 1. 1 times 1 is 1. You should notice a pattern is repeating here. I to the ninth, one way we can do that is, I could say a bunch of things. I can say I to the sixth times I to the third if I wanted to. Or I can say I to the eighth times I to the first. A whole bunch of different ways we can do that. Well, I to the eighth power we saw is 1 times I gives us I. Forgot to circle this one down here. And then we have I to the 10th. That could be I to the 9th times I if we wanted to do it that way. We could say it's I to the 8th times I squared. Sorry, that's missed there a little bit. Either way you do it, you should get the same thing. I to the 8th is 1, I squared is negative 1, so this gives me negative 1. So the pattern, I guess, if we're looking for it here, we started out with I in the first one. Then we had negative 1, negative I, 1, and then we were right back to I again. And that pattern repeats itself. I, negative 1, negative I, positive 1. So every 4 powers, it's going to repeat itself perpetually. And if we keep on going, we'll see this pattern repeat itself over and over and over. So that's a little bit about the powers of I. Now we're going to talk about how to add and subtract complex numbers. This is a relatively simple procedure. What we're going to do is we're going to add basically like terms. 8 plus 5 makes 13. 2i plus 4i is 6i. And that's all there is to that. So pause the video, give the next few a shot, and then resume it and see if you get what I get here. So here, 3 plus negative 8 is going to give me negative 5. 7i plus negative 2i is plus 5i. Here's a subtraction one. The only caution I can give you here is that we have to distribute this minus sign through the parentheses. That's what people do tend to forget if they're going to forget something. So 5 minus 3 gives me 2. Negative 4 minus 2 is negative 6i. And one more down here for subtraction. 6 minus negative makes plus, so 6 plus 5 is 11. That's the real part. Negative 2 minus a negative makes plus, so negative 2 plus 6 is plus 4. So that's the adding and subtracting part. We'll take a look at now is when we multiply these things. Well, this works just like FOIL. So if I'm going to multiply this, I'm going to do FOIL basically. I'm going to take 2 times 4, that's 8. I'm just going to basically distribute is what I'm going to do. So 2 times 5i is 10i. I'm going to write this one out so we can see what's going on here. The inner products, 3i times 4 is plus 12i. And then at the end, 3i times 5i, that is 15i squared. Now this goes beyond just adding these like terms, because if we look back here about I squared at the previous slide, or the one where we did all the powers of I squared is negative 1. So this allows us to take this a little bit further. We basically have here 8. Now these like terms make 22i. And since I squared is -1, this is actually minus 15. So now, to combine all like terms here, 8 minus 15 gives me -7 plus 22i. That's how we multiply two complex numbers. So once again, give this video a pause and give yourself an opportunity to try these few problems beneath here that I have, and I'll go on and do this, and you can resume and check your work. So I have 8 times 2, 8 times 4i, -3i times 2, and I have -3i times +4i makes -12i squared. That's going to become a plus 12, because I squared is -1. So 16 plus the 12 makes 28. 32i minus 6i is 26i. And that's what that product is. Your calculator has the capability of doing this too. I can show you that in class if you're interested. There's a few more. Again, pause and retry these, and pause and resume the video as you need. So I'll go ahead and do this. -6 times 4, -6 times +3i, -i times 4, and -i times +3i. Making note that the I squared is -1, which makes this really +3. So that makes this -21 when I combine it with the -24 here. And the i's are like terms, so I'm going to add those, -22i. This one here, a little bit different. I wanted to throw something a little different in here. This one is just a distribution here, so 5i times 2 is 10i, and 5i times 7i is 35i squared. And that makes -1 times 35, so that's -35 plus 10i. So that's it for the multiplication. Here I have a concept called complex conjugates, and I'll explain what these things are briefly, but I'm going to do this in a different video. So I'm going to pause this, end this video, and we will resume.